Kia ora, here's some more of the Level 2 Algebra exam from this year. This is question 2, parts A, B and C. So the focus in all of these questions is on quadratic equations, and the first one is one where we just have to solve this. So first we need to multiply everything through by x, and then we need to rearrange. So we start off like this. So I'm going to times both sides through by x. That gives me 3x squared minus 14x equals 5. And now getting that into our usual form, we get 3x squared minus 14x minus 5 equals 0. I know some of you are going to put that in your calculator, and I think that's fine here, but I'm going to show you two ways to do it. With this one, because these are both prime numbers, I'm going to be pretty confident that I can do easy guess and check to get this one to work, right? Because these two have got to be a 3 and a 1, and then the 5 has got to come from either a 1 and a 5 or a 5 and a 1. And I think by this point, you've done enough quadratics that it should feel pretty easy to see that that minus 14 is going to come from having a minus 5 here and a plus 1 here. So let's just get rid of those little numbers and check that that's going to expand out properly. And you can see that it does. We've got 3x here, plus 1x minus 15x minus 5. So that works well. I'll finish this off, and then I'm just going to quickly revise how we solve that with grouping as well. So here we have 3x plus 1 equals 0, or x minus 5 equals 0, giving me x is equal to negative a third, or x is equal to 5. Okay, so that's my final answer for that one. There we go. Right, but just reminding you how we do it with grouping. If you didn't see how to split that up and you didn't have a graphics calculator, we've got two numbers. We have to have something times something equals this one times this one, so negative 15, and something plus something, giving me this coefficient in the middle of negative 14. So let's put in 15 and 1, and 15 and 1 here. And we want to have negative 14 here, so we need to have the negative with this one and not with the other one. That means that I can split that up into 3x squared minus 15x plus x minus 5 equals 0. The next thing to do is just to factorize it in 2 steps. So here we're going to get 3x times x minus 5 plus no obvious common factor, so it's plus 1 times x minus 5 equals 0, and we get back to what we had before. Okay, I realise most of you watching will probably just want me to get to the answers because you've just done the exam, but this is in case there's anyone from the future coming back and not knowing how to do grouping for solving quadratics. It is a pretty useful strategy, and that's my way of doing it. Other teachers will teach you different ways, okay, and they're all fine. Right, this next one is also a quadratic and a pretty straightforward one. You should look at this and go, look, we've got to factorize that to do anything with it. If it's sitting under the square root sign, it's got to be a perfect square or we can't get very far. So we've got this divided by 5x plus 3x squared. Let's start with the easy factorizing in the denominator. We have x into 5 plus 3x. So we should be expecting that to pop up here, and it does. You can see that I've got a square number here and a square number here. So let's just see if that works. And happily it does. So 3x plus 5 times 3x plus 5. Let's just check. We've got 9x squared plus 15x and another 15x gives me 30x plus 25. That gives me, when I take the square root of the square, I get back to 3x plus 5 over x times 3x plus 5. That term there, and that leaves me with 1 over x for my final answer. Okay, so both of those first two, I think, are just testing pretty mechanical skills with quadratics, but this next question, you need to have a bit of a think about what's going on. And if you've done enough pattern spotting, I think you'll see how to do this next one. So find the value of k for which this equation, which looks bad, but is going to be just a quadratic, has roots numerically equal, but opposite signs. For example, 2 and negative 2. So before we start dealing with this mess, let's think about what happens if my roots are numerical and opposite signs. So this one would be x minus 2 times x plus 2. And you've seen that lots of times before because that's the difference of two squares pattern. So to get roots that are numerically equal but opposite signs, we have to have bx. The b has to equal 0. The other way that you can see that is if you look at the quadratic formula. And if you just focus for a minute on the plus or minus bit, right? In order to get the roots being equal and opposite sign, this is my negative b, right? And I'm going one way in each direction. For example, if I had the square root of 10 under there, the only way that I'm going to get out a negative root 10 here and a positive root 10 here is, again, if that thing there is 0, right? So you're thinking of, I can think about it as a seesaw in a kid's playground. This is the middle of the seesaw, and it's going to go, I don't know, this is a bad picture of a seesaw, but it's going to go up or down when someone sits on either end. And if this number in the middle is something like 3, then this one is going to be 3 plus root 10, and this is going to be negative 3 plus root 10. And they do not work out to be the same value but of opposite sign, right? So what we're looking for in this question is just to find what k value gives us b equals 0. Right, so I'm going to go through that pretty slowly now. We've got a bit of a thing to sort out with the equation not yet looking like an easy quadratic, but that's going to be fine. We just have to remember how to work with fractions. So I'm going to start by multiplying both sides by this and multiplying both sides by this. Because we're working at level 2, I'm going to do that in one step. If you've got problems with that, ask me or ask your teacher. So we've got k plus 1 times x squared minus 2x is equal to k minus 1 times 4x minus 1. I'm going to expand everything and then gather up like terms. So kx squared plus x squared minus 2kx minus 2x is equal to, so that's these ones all done. Now we're going to do 4kx minus 4x minus k plus 1. To solve a quadratic, we want to have it all equaling 0 and all the stuff on one side. So my next step is to get all of this to the left-hand side. I'll leave it all expanded in this step, and then we'll start cleaning up next. Now I have minus 4kx plus 4x plus k minus 1 is equal to 0. And it's worth at this stage just checking that you haven't mucked any of those steps up. So pause the video and just check that the expanding is correct, because it's very easy to make a mess. Okay, so that all looks okay to me. I'm just checking it with my notes. It's better to spend the time to check than to rush through and get it all wrong. Now my next step is to get this into a quadratic in ax squared plus bx plus c equals 0 form. So I'm looking for like terms now, and I'm going to have a way of ticking them off when I've found them. I've got k plus 1x squared, and next I've got minus 2kx minus 2x plus 4x minus 4kx. So I'm going to write that as plus x times minus 2 plus 4 gives me 2. So I've got 2x here, and I've got minus 2kx minus 4kx gives me minus 6k. And lastly, I've got k minus 1 here. And that all equals 0. I'll just get rid of that. So for equal roots, equal and opposite roots, we must have b equals 0, which gives me a pretty simple equation to solve at the very end. We're going to get k is equal to 1/3. Now, the question didn't, I'm just having a look. That's as much as I think we have to do for this question. But I think we've got this far. It would be good to see how that actually works with our equation. So if k is equal to 1/3, what is k plus 1? k plus 1 will be 4/3, and this will be 0, and k minus 1 will be negative 2/3. So that leaves me with this equation, 4/3 x squared minus 2/3 is equal to 0, giving me 4x squared minus 2 equals 0, timesing through by 3. Remember, you didn't have to go this far, right? So the end of the question is here, but I'm just doing the next step because I think it's interesting. And here we've got 2x squared minus 1 equals 0, or x squared is equal to 1/2. So you can see that that has kind of crashed down into an equation where x is equal to 1 over the square root of 2, or negative 1 over the square root of 2, which fits what we were told about the problem, because it's got roots that are numerically equal but opposite signs. Okay, so there you go. I think, I don't know how they're going to mark that. If it's a merit question, I think it's quite a hard merit question, honestly, but I think it's a nice question because it just works with what you know about quadratics. And if you think deeply about all of the things that you've learned this year about quadratics, it's not too bad, right? So to get numerically equal roots, how do we do that? You can think of that either as a difference of two squares, or, as we did earlier, think of it with the quadratic formula. And then you work your way through logically from there, and the equation that you get is a pretty simple one. But there is that manipulation to do first, coming out of the fraction. Okay, I'm not going to do any more of the level 2 papers probably until Tuesday or Wednesday. I'll keep going on the calculus one then. Thanks for watching.